Hey, college algebra kids. Today we're looking at solving systems of equations, two variables with graphing and substitution. Solving systems, linear equations, graphing and substitution. Notes out, and here we go. You looked at these again in Algebra 1 and Algebra 2, and we're going to look at them again. Solve systems of equations by graphing. So there's three methods. We're looking at two today: graphing and substitution. And then tomorrow we'll look at elimination, the third type. All right, here we go. How do we solve by graphing? Well, we're going to graph the two equations. So y equals x plus 2. We know from last chapter 0, 2 is the y-intercept. We know the slope is 1 over 1. And so we can plot the points, up 1, down 1, up 1, right 1, down 1, left 1, to plot the points. And then if I do fancy and get a different color, we need to solve for y first. We need to subtract x both sides. So y is negative x plus 4. So our y-intercept is 0, 4. And we're going down 1, right 1. And if we do these right, it should intersect at some point. Here, that point was 1, 3 is the ordered pair. Now we're going to answer every system of linear equations in an ordered pair. But here we see y because it's going to be a solution on a graph. Now the nice thing about all of these problems is we can check to see the answer. And that is x has to be 1, y equals 3. So we can go back and check, does 3, the y value, equal 1 plus 2? Yes, it does. So there's our check step. On the second problem, does 1 plus 3 equal 4? Yes, it does. So we can check our solution simply by plugging the ordered pair back into the equation. Chapter 2, or example 2, same thing. We're going to solve for y. So here we have 2y plus 4 is equal to x. 2y then is equal to x minus 4. Now we want to divide everything by 2. So y is equal to 1/2 minus 2. On the second equation, again, we want to solve for y. So negative 2y is equal to negative x plus 4. We'll divide everything by negative 2. And therefore, y is equal to 1/2 x minus 2. And what do you notice? Well, what happens here is we actually get two lines, but they're the same line. So again, our slope, our y-intercept is 0, negative 2. Our slope is 1/2, so we're going up 1, right 2, up 1, right 2, down 1, left 2, down 1, left 2. And then when we plot our second equation, it's actually right on top of it. So what happened? Well, we get the same equation, and so that's got to be which case. And let me get back here to my notes. All right, we call that in algebra infinitely many solution. We can also then use our graphing calculator, right? You have this fancy calculator, and we can do graphing. How are we going to do that? We're going to go to the y equals, and that brings up our y equal buttons. There's a bunch of options here that we'll go through. The only thing really to play it with now is the color. You can change the color. And to do that, you just got to go back and hit enter, and then you can change the options for the lines. You can play with those and see how that works. But let's go back to y equals, and we'll just type in our 2. Now we have to type in the solved version for y. The calculator won't do that for you. You got to type in the solved version for y. So for x, we're going to use the x button. That x button is to the right of alpha. So there's our x. We can't use the alpha x. We're using that x button there. Plus 2. We'll go down to our second equation. We'll type in, again, solve for y. Y is negative x plus 4. And again, that x has to be that x button right there to the right of alpha. And then when we hit graph, what we should see are those two lines that come through and plot. And you might be able to look at it and kind of guess where it is, but there's actually a button on the calculator that will find where those two lines intersect, and that's the intersect function. To find that, we're going to second calc. Let me write this down for you. Second calc intersect. So second calc is the second trace, and we want intersect. I'm just going to put a flasher on one of the lines. We're going to hit enter. It's going to put a flasher on the second line. We're going to hit enter. It's going to ask to guess, and we're going to hit enter again for the third time, and it's going to give us the intersection, which was 1, 3. Okay, there's how to use your graphing calculator to find the intersections. We could do that with our number 2, but it's the same line. There's definitely many solutions. And we're going to look at example 3. Again, the first thing we want to do is solve for y. So this is, we want to subtract 2x to the other side. So negative 3y is equal to negative 2x plus 6. We're going to divide everything by negative 3. And so y equals 2/3 x minus 2. So again, our y-intercept is down 2. Our slope is up 2, right 3. And we'll do the same thing for the second equation. Solve for y. 3y is equal to 2x plus 3. Y is 2/3 x plus 1. 3 divided by 3 is 1. So we're right here. Slope is 2/3. And what do you notice here? Well, here they have the same slope. What do we know about same slope? Same slope means they are parallel. Well, if they're parallel, can they ever intersect? They can't, so this one has no solution. We're going to have names. So we actually saw 3 different things that occur. If we graph 2 lines on a coordinate plane, they're either going to intersect at one point, they're going to intersect at every point, so that's infinitely many, or they're not going to intersect at all. And we're going to have names for those. We're going to call a system that has at least one solution a consistent system of equations. If it has no solution, we're going to call it an inconsistent system of equations. If it has exactly one solution, it's independent consistent. And if it has infinitely many solutions, it's the same line, we're going to call it dependent consistent system of equations. Next thing we're going to look at is solve by substitution. To solve by substitution, we're going to solve for one variable, plug that expression into the other equation, and solve. And this was solved by substitution. Now on an assessment, you would need to show this process being illustrated. In example 4, we have a choice. What we're usually going to do first is look for what's the easiest variable to solve for. The easiest variable to solve for is no coefficient. So if we can solve for no coefficient, that's going to be the best thing we can do. In example 4, we have to pick. It doesn't really matter which one you do. I want to solve the first equation. I want to solve for the y. Well, it's already solved for y. And we get 2x minus 3. And so I'm going to replace that in the second equation with the y. So there's my substitution. I'm taking out this y because we know this y is equal to 2x minus 3 and plugging in. So again, I'm replacing this y with 2x minus 3. That's going to equal x plus 5. We're going to solve from there, subtract x, add 3, and we get x is 8. And there's our x value. We just need our y value. I'm just going to use the second equation. Y then is equal to 8 plus 5, which is 13. Now again, to answer our system of equations, we're going to always answer as an ordered pair. So here the ordered pair is 8, 13. We also want to identify what type. This is independent consistent because it had one solution. Consistent because it had a solution, independent because it had one solution. Now again, there's still a check step. That check step is still plug that ordered pair back into the original problem. So if I take 2 times 8, I get 16, minus 3, that's 13, and that's our y value. So it still checks. Same thing on the second equation. 13, does that equal 8 plus 5? It sure does. So again, we can plug back that ordered pair to check to make sure we have the right equation. Same thing with example 5. What variable will I want to solve for to use solve by substitution? Well, here, there's a variable with no coefficient. That's usually going to be the best. So I'm going to rearrange that equation. So y is equal to negative 2x plus 6. So I'm going to pick one equation. I'm looking for the variable that has no coefficient. Plug to solve for that variable. It can be an x or a y. It doesn't matter. Now we're going to take that expression and we're going to plug it in for y into the other equation. In this case, it was the first. This is going to turn into a giant distributive property problem. So here we go. I'm starting with the first equation. This is 2x plus the coefficient 3. Notice this whole thing has to be written as distributive property. I'm taking the y, which we just solved for, this expression, and plugging in. We get negative 2x plus 6, and that equals 8. So there's my algebra equation. We just solved from there. Distributive property gives us minus 6x plus 18 equal to 8. We want to combine like terms. 2x minus 6x is negative 4x. Minus 18 gives us negative 10. Divide by negative 4, we get 2.5. There's our x value. We're almost done. We need the y value to get that. We'll plug back into this equation to find y. So y is equal to negative 2 times 2.5 plus 6. Plug that into our calculator, and that is 1. So I get 2.5 and 1. Again, it's going to be an independent, consistent equation. Again, I can check it by plugging back into the original problem. I'm always going to say the original problem because what if we'd made a mistake solving for y? We want to eliminate that. So here we go. We're going to take two x's. 2.5s is 5, plus 3 1s is 3. 5 plus 3 is 8. There's our check. Second equation, y is 1, plus 2.5s is 5. As we said, 1 plus 5 is 6. So there's our check step, and it works. All right, what's some of that other weird stuff that can happen? Let's look at example 6. Again, here we have an equation that's already solved for a variable, so we'll solve for y. So we're going to just leave that y there. And then every time in the first equation where we see a y, we're going to plug in our x minus 5. Now you could simplify the first equation a little bit if you wanted to. I'm just going to go ahead and plug it in. So here we go, 2x plus 3. This has to be distributive property. Y, but we know y is x minus 5, is equal to 5 plus x plus 4. Again, there's a y, but I know y is x minus 5. And let's see what happens. Simplify, we'll use distributive property, plus 3x minus 15 is equal to 5 plus x plus 4x minus 20. Again, let's combine like terms. 2x plus 3x is 5x minus 15. That was a 4x. 4x plus x is 5x. Plus 5 minus 20 is minus 15. Look at both sides. And what do you notice? This is an identity, which means there's infinitely many solutions. We're calling that then, technically x is the reals, but it's not just an x, so we're now x and y, so that doesn't really count anymore. So now we are dependent, consistent. Consistent because it has a solution, but now it's dependent because any solution is a solution. There's an infinite number of solutions. And example 7. What's the easiest variable to solve for? I'm going to solve for this x by adding a 2y to each side. So x is equal to 2y plus 3. So now I'm going to plug that into the second equation for x. So there's our substitution. So we have 2 times 2y plus 3 minus 4 is equal to 7. We'll use distributive property. That's 4y plus 6 minus 4 is equal to 7. And that was 4y. I missed that. That was 4y. So what happens to plus 4y minus 4y? That cancels to give 6 is equal to 7. Can 6 equal 7? That can't happen. This was no solution, which we're going to define as inconsistent. You do need to include the type of equation if the directions ask for it. Here's your homework assignment for lesson 4.1. Page 233, problems 8 through 20 evens, 26 through 34 evens, and 46 through 70 evens. Have a good day, kids. See you in class.